Welcome to another video of Engineering Economics, INEN 2373. We are going to discuss the equilibrium in economics, and for that we're going to consider making a graph that looks like this. So what we have here is, in the horizontal axis we have the quantity, and in the vertical axis what we have is the value expressed in dollars per unit. And as we've seen before, the consumer is going to depend on the marginal utility, which is expressed by this graph, and the more the consumer needs or consumes, the less value it feels it provides adding a new unit of this product. At the same time, producing ever more larger quantities for the producer, it brings marginal costs that are larger. So this is the equation for marginal cost. This is the equation for marginal utility. This translates then into a supply curve, and this translates into a demand curve. And pretty much what we have here is that these two curves are going to meet about here at this point, and that's where both would be interested in trading. At this point, the supplier is interested in keep supplying the product, and it will not supply at any higher value because it would be too expensive for him to continue to make profits. And that means that this is the number of units that is going to be traded, and this is the price at which is going to be traded. So that means that if this is the line of the supply, then only that many units are going to be provided. As we have seen before, this region here represents the consumer surplus, and now we have that since the marginal cost is the derivative of the total cost, if we integrate this area with respect to Q, that is, we compute this area under this marginal cost, then this will be the total cost. Actually, it's just the variable cost because we have not included the fixed cost in this graph. And this would be a measure, this area here, it's a measure of the profits. And we can compute that if we knew what the values for these different regions are. So let's consider that. Okay, let's consider a situation in which the marginal utility is 100, that is, at a price of 100 we would be willing to consume 10 units. And at a price of 30 we will be willing to consume much more, 360 units. At the same time, for the supplier's perspective, if the price that we can get in the market is $100, we're willing to supply 553 units. But if the price in the market, the cost that we have, is 30, then we're only willing to supply 63 units because our marginal cost implies that that's the cost. So when we have that, we can compute the slope of the marginal utility as the difference in marginal utilities. That's 100 minus 30 divided by the quantity that we are increasing, that is 10 minus 360, and we end up with a negative slope of 0.2, and by substitution we can find the intercept to be 102. In a similar way, we can compute the slope to be the difference between the prices of or the marginal cost at different levels of operation for the producer. So we subtract 100 minus 30 as the marginal cost and divide that by the difference in the number of units, which is 553 at the highest level and 63 at the lowest level. So that gives us a yield of 0.142857, which is 1/7 positive. So now we have a slope and an intercept for the marginal utility and a slope and an intercept for the marginal cost. And if we set those equal, we would find the expression 102 minus 1/5 times Q should be equal to 21 plus 1/7 times Q. That's the equation that we have by applying these values that we got for the slope and the intercept, and both should be the same. The price should be the same. So when we solve this in the equilibrium, so when we solve for this, we find that Q is 236. All we have to do is solve for Q, which is 81 should be equal to 1/5 plus 1/7 times Q. And when we do the math, 81 times 35 divided by 12 is going to be Q, and that number is $236. By plugging in these $236 in the equation for the marginal utility that we obtain either in this half or this half, we obtain that the price is at which we trade is 54.75. Therefore, the area for the revenue is P times Q. We get P times Q 12,934, and the consumer surplus is going to be the region above the transaction, above the revenue in the triangle. We can compute that as a function for the triangle, and that would be, well, the height of the triangle. If the intercept is 102 for that line and the price is 54, we subtract from 102, we subtract 54.75. that gives us the height of that triangle. We multiply that times the base, which is the number of units, 236, and in a triangle we need to divide by 2. When you compute the number, you obtain $5,581. In a similar fashion, we can compute the profit. Profits are the difference from the intercept for the marginal cost, which is 21, to the price. The price is 54.75. So we compute that difference, and then we multiply that times the number of products that we sell. That's 236.25, and again divided by 2 because it's a triangle, and that gives us a profit. Finally, by difference, if the if the revenue is 12,934, then the cost is going to be the difference, which is the revenue minus the profit, and the cost is 8,947.97, and that's how you do it. Thank you.